Okay, so hello everyone, and thank you for attending my presentation today, titled Elevate and Conquer, Unleashing the Power of High-Level Endpoints in Scala. My name is Jorge Vasquez, and I'm a Scala developer at Cyberge. So, well, traditionally, developers have relied on constructing routing tables to build their REST APIs. These tables map specific routes to corresponding request handlers, and well, doing this involves manual decoding of headers, query parameters, and request bodies, and also involves manual encoding of responses. So that all of that sounds very low level, right? And so we'll see that problem in action now. We'll see an example of launching a web service using a low-level approach. We'll implement an example, a shopping cart API, with the following endpoints: initialize cart, add item, delete item, update, and get cart contents. So let's do that using the ZIO HTTP routes API, which is the low-level API offered by the ZIO HTTP library. So to do that, you just need to include ZIO HTTP as a dependency. And by the way, I'll be using the latest release candidate. It has been released some days ago and includes some new features. So I'll be using that. So, well, the first step for implementing our API will be to define some domain models, right? Like I have here a user ID, an item ID, and I'm writing here some implicits. I'm going to need some JSON field encoder and decoder from ZIO JSON. I have here a model for an item. So this will represent items in the shopping cart. And here you can also see that I'm deriving automatically a JSON codec from ZIO-JSON because I'm going to need that to decode requests and also encode responses. I have this model for items that internally contains a map. So this will represent the shopping cart with all its items. And I'm also automatically deriving a JSON codec. And I have this update item request model, which I'm going to need later as well. So that's it. And the second step will be to define this routing table I was mentioning before, right? So to define routes, we will need to write path segments, path variables, validations, and handlers. So basically in ZIO HTTP, you need to create a routes object. And for each route, you need to provide a mapping from a path to a handler, right? So in this example here, I'm saying that for the initialize card endpoint, I will accept post requests to this card user ID path. And here you can see that I'm validating that the user ID passed as a path parameter should be a UUID. And I'm associating this path to a handler. A handler is basically a function that returns a ZIO effect. And you have to do something similar for the rest of the endpoints. So that was easy, right? The third step will be, well, to start implementing this, right? So here I'm defining a card service. This is a typical ZIO service. So here you can see I have the trait with some methods, and I have a live implementation here. And also I have a Z layer here for instantiation of the live implementation. So that's classic ZIO, right? There's nothing special there. For the next step, I'm going to define the handlers. So before I had associated routes to handlers, but here's the implementation of them. So I have handle initialize card here, for example, to handle the initialize card endpoint. Here you can see every handler receives some parameters. In this case, because I have a user ID in the path, I'm receiving that as a parameter in the method, right? And also every handler will have access to the request object, the whole HTTP request in case you need it, and you need to return an HTTP response. So here, for example, I have to manually define this HTTP response. In this case, I'm saying the status code will be no content. For handle add item, you can see it's a more complex implementation. Again, I'm receiving input, the user ID input as a parameter, the whole request object. And here it's more complex because I need to decode the request body as JSON, handling errors at the same time manually. And also I have to manually obtain a header. In this case, I want to read this XOL items header, and I need to manually validate it again. So you see there's a lot of manual stuff going on here. And I have to also, again, manually encode the response as JSON. So you see now this low-level feeling here, right? I need to decode request, encode response, and that happens for every handler, right? Here I have handler remove item. In this case, I'm receiving two variables, user ID and item ID, because, well, the user will send them in the path. I have the request object, and I need to return a manual response again, something similar for update item. Again, I need to do manual decoding, manual encoding of the response. The same for get card contents. In this case, I have to manually obtain and validate a query parameter, this limit query parameter. I need to validate that is a valid integer in this case. Again, manually encoding the response as JSON. So all of that was so boring and repetitive, right? And the other limitation here is that, well, we have written all this logic for the server, but there is no way to automatically have a client and documentation generated for us. So we have nothing for free. So the question, as always in software engineering, is that is this one? Can we do better? And the answer is, well, come on, of course we can do better, right? So we can use high-level endpoint libraries. So Scala, the Scala open source ecosystem, offers us superior alternatives for API development. We have libraries such as Endpoints for S, Tapir, and ZIO HTTP, which enable developers to define endpoints at a higher level. They eliminate the need to handle decoding and encoding manually, and also they provide benefits like open API documentation and type-safe clients totally for free. So, well, that sounds a lot better, right? And another advantage of using these endpoint libraries is that we have a single source of truth now for our server, client, and documentation. So if we do some change to the endpoints, which are high-level definitions of our API, those changes will be reflected everywhere. So that's nice. So let's see an example for implementing the shopping cart using the Endpoints for S library. So to use Endpoints for S, you are going to need to include several dependencies in your project. For example, I have these core dependencies from Endpoints for S to define algebras, to be able to automatically derive JSON schemas. I'm going to be generating an HTTP for a server and client, and also Open API documentation. So I need to include dependencies for that. And well, as you may know, Endpoints for S allows us to generate several kinds of servers and clients, right? So, well, I'm choosing HTTP for S in this case. And well, I have here the specific libraries from HTTP for S for the server and the client. And I'm also going to need this interop library with cats. So, well, the first step will be similar to what we had before. We have to define some models. So, well, I'm adding here this effect type alias that I'm going to need later. I have the item ID, user ID, the same as before. This item model, it's also the same. The only difference now is that you can see I'm adding this docs annotation to every field. And this is useful to add some documentation that will be included in the generated Open API docs later. I have the model for items and for update item request. The second step now is to define endpoints. So these endpoints are high-level descriptions of our API. And when you work with endpoints for S, you need to extend to implement several traits. So that's something interesting in endpoints for S that can make things a little more complex because you need to know which traits to include. So in this case, I'm including this endpoints algebra trait, another trait for being able to derive JSON schemas, JSON entities from schemas, and so on. Okay, so once you have the right traits, you can start implementing the endpoints, right? You need first to define some implicits, these implicit JSON schemas that are needed for encoding and decoding requests and responses. So in this case, for example, I'm automatically deriving this JSON schema here for item. For items, for this items class, I can't do it automatically. I need to do a lot of manual validation here, so that's not very nice. And that happens because this items class internally contains a map, right? And there is no automatic way of deriving a schema for a map. So that's the reason of this manual stuff here. I can automatically derive the schema for this update item request object. And once I have this implicit, I can start writing the endpoints. And before that, well, I have some common variables here, like this user ID that will appear several times as a path segment in the request. So I'm defining it as a segment together with the corresponding documentation. Something similar for item ID. I will need this limit query parameter. So you define that using this QS method from Endpoints first. And once I have those, I'm defining here the endpoints themselves. So to create an endpoint, you call this endpoint function. And for example, here I'm defining initialize card. So I'm defining the corresponding HTTP method and path. In this case, this will be a post request. I have the corresponding path. The request body will be empty, so I'm defining that here as well. And the response body will be empty, but the status code in case of success will be no content. And I'm also adding the corresponding docs. So that's it, very high level. Then you have something similar for add item. In this case, there is more information. I have the path. The request body will be an item object, and I'm expecting it to be encoded as JSON. I have this XOL items header, and again, here I have to do some manual validation because, well, Endpoints for S always gives you access to the headers as strings, but I want to transform it to an option of a Boolean, so I have to do manual validation here because of that. And for, well, in the case of success, I'm going to return an OK status code, and the JSON response will be of type items. And I'm adding the documentation for the whole endpoint here. And it will be something similar for the rest of the endpoints for remove item, update item, and get card contents. Well, something interesting here in this endpoint is that I'm going to need this limit query parameter. So here you can see how you can define query parameters using the endpoints for S syntax. So now that we have the endpoints, we can generate a server from those endpoints. So in this case, as I've mentioned, I'm going to generate an HTTP4S server backed by ZIO. So, well, again, you need to include some traits from the endpoints for S library, the traits corresponding to an HTTP4S server. And once you have that, you can start implementing the logic of the endpoints. Remember, the endpoints are high-level descriptions of your API, but you haven't provided the internal logic yet. So here we're doing that. So you just call this implemented by effect method, and you provide the corresponding logic. In this case, the logic will be just a ZIO effect. And here you can see I'm receiving a user ID as a, well, it's a user ID, a domain model, right? And I'm just returning units. So that's great. Here you can see I'm just working with domain models. I'm not having to deal with HTTP requests and responses as I needed to do in the previous example. And I have something similar for the other ones, right? In this case, for add item, I'm receiving more inputs, right? But they are still domain models, right? And I'm returning an items object, which is also a domain model. So there is no encoding and decoding happening here. And well, it's the same for the rest of the endpoints. And once I have these implemented endpoints, which are called routes in Endpoints first, I can combine them in an HTTP routes object that I can provide to the Blaze server builder, typical way of building an HTTP for a server, and that's it. But wait, there's more. You can also generate a client, right? Because now we have this high-level endpoints definition, you can also generate a client from it. So how you do that with Endpoints for S, you need to instantiate, well, I'm going to instantiate an HTTP for S client backed by ZIO in this case. Again, with Endpoints for S, you can generate different types of clients, but well, that's my election for this example. And well, here I have to admit that the way to instantiate the client, it's not very easy. But basically, I'm extending again some traits from Endpoints for S that correspond to an HTTP for S client. And I'm defining the server host, the server port. And once you do that, you can use that client to call your endpoints by calling this send and consume method, where you just provide domain models as inputs and you get domain objects as outputs. There is no encoding and decoding that you need to do, so that's awesome. And well, everything will work with ZIO, so you can combine these ZIOs in for comprehensions as you would normally do. So that's nice. But wait, there's still more. You can generate documentation, right? And in this case, I'm choosing to generate an open API documentation. I'm extending the corresponding traits from Endpoints for S. And once you do that, you can call this open API function, where you just provide the list of endpoints you have defined, and that's it. You can do whatever you want with the documentation. For example, in this case, I'm converting it to JSON and printing it to the console. So that's awesome, very easy to do. So that was the example with Endpoints for S. Now let's do the same, but with Tapir, the Tapir library. So again, you need to include several dependencies. First, I'm including the core dependency from Tapir. I'm including the HTTP4S server dependency because I'm going to generate an HTTP4S server again in this case. Similar to the Endpoints for S case, you can generate different kinds of servers, but I'm choosing this one again. I'm including a dependency to be able to work with ZIO JSON here. I'm going to be generating an HTTP client, so I'm including the corresponding dependency as well, including the Open API dependencies, so I'm able to generate Open API documentation. Here I have the HTTP for a server, the ZIO version of HTTP, and the interop library with cats. So the first step, it's again to define models. This is again the same as before. We have this effect type alias. I have item ID. Again, I'm going to be using ZIO JSON, so I need to include this implicit user ID. I have the model for item, very similar to what we had before. The difference is that now we have this description annotation that comes from Tapir in this case and will be used when generating the Open API documentation. Remember, in Endpoints for S, we had some similar annotation, but this one is specific to Tapir. And also some other interesting difference now is that Tapir needs these schema objects. So this schema data type is one that comes from the Tapir library, similar to ZIO schema, but well, specific to Tapir. And you can see I'm automatically deriving it for this item class. I have the items model again, and I'm also needing, I will need a schema object for this class, but well, in this case, I can't automatically derive it. As you can see, I need to do some manual stuff. And again, similar to what happened in the Endpoints for S case, this happens because this items class internally contains a map, right? And there is no way to automatically derive a schema for a map. So that's basically what's happening here. And I have the update item request object again. Next, you can define endpoints. And now a big difference compared to Endpoints for S is that I don't need to combine all these several traits like I needed to do in Endpoints for S, right? So I think that's a lot nicer because you don't need to know which traits to combine and stuff like that. You just start writing your endpoints. So here I'm defining some common variables, this user ID, which will be a path variable. This is very similar to what we had in the Endpoints for S case. I have something similar for item ID. I have this limit query parameter and this Excel items header. And something nice here compared to HTTP4S is that you can see I can define the type of header I want. In Endpoints4S, the type is always set to a string, and I had to do some manual conversions. But here I can say that I want it to be an option of a Boolean, and that's it. I don't have to do any manual transformation. And now I can define the endpoints. The syntax is very similar to Endpoints4S. I first define the HTTP method, in this case, post for initialize card. I define inputs. In this case, I will have a user ID input in the path. The output will be a no content status code and the description for the whole input. For that item will be something similar. I will accept post request. I have this user ID in the path. But in this case, I'm going to accept additional inputs. So I have this Excel items header. I will also have the a request body, which I want to decode as an item object. And the output will also be a JSON, but in this case of type items. And I have the description for the whole thing. And well, the syntax is very similar for remove item, update item, and get card contents. And well, this get card contents, let's remember it receives this limit query parameter, and you just provide it as another input. So that's it. And now that we have the endpoints, we can generate a server. And again, I'm going to generate an HTTP for a server backed by ZIO. You don't need to include several traits as it was the case with Endpoints4S, so that's nice. And how you implement endpoints by calling this zserver logic method from HTTP from Tapir. And again, very similar to the previous example, we are just working with domain models, right? I don't need to encode and decode. So this is basically the same, very similar to what we had with Endpoints4S. So that's nice. And once you have implemented all the endpoints, so you have these logic objects, you can combine them and provide them to this ZHTTP4S server interpreter, which will give you an HTTP routes object that you can use to initialize your server as you would normally do. And well, I know you want to see the bonuses, right? We are going to generate a client here. In this case, I'm going to generate an HTTP client. And so to do that, I'm going to, well, because I want it to work with ZIO, I'm instantiating here a ZIO backend. I'm defining the server address here. And now I need to instantiate clients. So a difference with Endpoints4S is that, well, in Endpoints4S, we could instantiate just one client and use it to call all the endpoints, right? In this case, I need to define several clients, one client per endpoint. So that's what's happening here. For example, here I'm generating a client for initialize card by providing the initialize card endpoint, the server address, and the corresponding backend. And you have to do something similar for other endpoints. And now that you have the clients, you can call them as normal functions. So that's awesome. Again, you just work with domain models and ZIO effects. You can use those ZIO effects, combine them in for comprehensions. So that's great. And you don't need to handle encoding and decoding again. You can also generate OpenAPI documentation. There is an OpenAPI docs interpreter in Tapir that you can use, and you just provide this the list of endpoints you want, and you can do again whatever you want with the documentation. In this case, I'm printing it to the console as a YAML. And finally, let's see again this shopping cart example, but now using the ZIO HTTP endpoints API. So, well, in this case, you just need one dependency, the ZIO HTTP library, and that's it. And well, again, the first step for doing this will be defining the models. It's the same models we had before. We need to again write some implicit for ZIO JSON. I have the model for item. It's the same as before. The difference here is that I'm using this description notation, very similar to Tapir, but now this notation comes from ZIO schema, not from Tapir. And I also need this schema automatically derived, but this comes from ZIO schema, not from it's not the same type we had in Tapir, also very similar. I have the model for items, and something interesting here, something great, is that if you remember in the case of Tapir, I wasn't able to automatically generate a schema for it. But in this case, because I'm using ZIO schema, I can automatically derive a schema for items, even so it has an items map inside of it. There is no problem. ZIO schema is able to automatically generate a schema for you, even if you have a map there. And I have the update item request model. And now I can define endpoints again. And the syntax is very similar to Tapir. Again, I don't need to combine several traits or things like that, like in Endpoints first. So I define, again, these common variables similar to the previous examples. I have this user ID, which will be a path variable, and I want to validate it is a UUID, something similar for item ID. I have this limit query parameter, and it should be an int. That's why I'm calling this param int function. I have this exfol items header, and again here I can provide the type I want for the header, right? I don't need to do any manual transformations or so. And now I can define the endpoints. The syntax is very similar to the previous examples. I define the HTTP method, the path. The output in this case will be a status no content. For at item, it will be very similar. I have the user ID in the path. I need a header in this case, this exfol items header. I will have an item as an input in the request body, and I'll have this items output that will also be automatically encoded as JSON for me. And well, it's similar for remove item, update, and get card content. And in this case, I needed a query parameter. So in the case of ZIO HTTP endpoints, you call this query method to provide the corresponding parameter you want. And now we can generate our server. In this case, we are going to generate a ZIO HTTP server. So a difference with Endpoints for S and Tapir is that the ZIO HTTP Endpoints API is just for ZIO HTTP. It doesn't allow you to generate servers for other libraries because that's not the idea. This is exclusive to the ZIO HTTP library. But well, the philosophy behind it is very similar. So you need to write some handlers, which are functions that return ZIO effects. And the inputs to these functions will be just domain models, and you just return domain models again. So there is no encoding and decoding happening here. So that's very similar to the previous examples. And once you have the handlers, you can create again this routes object as we did in the first example with the low-level API. But now the difference is that to this routes object, you have to provide the endpoints you have defined, like initialize card, and you call the implement method. And you need to provide the corresponding handler, and that's it. So something interesting here I want to highlight is that the syntax, the low-level API syntax for defining routes is very similar to the high-level endpoints API in ZIO HTTP, right? So that's something very nice and a very great change, I think, in the latest versions of ZIO HTTP. And once you have your routes, you can initialize your ZIO HTTP server as you would normally do. And well, it's bonus time. We have here a client. You can automatically use your endpoints as clients. For that, you will need to obtain an endpoint executor from the ZIO environment. And once you have the executor, you can execute your endpoints as functions. And you call these functions by just providing domain models. And you are going to obtain domain models as well as outputs inside ZIO effects. And well, when you instantiate your client, you just need to provide this endpoint executor as a layer, and that's it. And now, thanks to the appear generated by Nabil, and that's included in the latest release candidate. Now we are able to generate open API documentation from our endpoints. So you just need to call this open API gem from endpoints method, and you provide all the endpoints you have, and that's it. You have open API. You can do whatever you want with it. In this case, I'm just converting it to JSON and printing it the console. And well, before I end this presentation, I have here a comparative matrix between these three libraries. So for example, seeing here the server backends that we can generate, you can see that Tapir is the one that gives you more options. It has more bigger variety of servers you can generate. Endpoints for us also allows you to generate different kinds of servers, but it has less options than Tapir. And as I have mentioned, the ZIO HTTP endpoints API just allows you to generate a ZIO HTTP server. Something interesting here is that Tapir allows you to generate an AWS Lambda function. That's interesting. That's an option that is currently not supported by the other libraries. For generating clients, well, Tapir and Endpoints for us have several options. So if you want that flexibility, those libraries are nice for that. And well, the ZIO HTTP endpoints API just allows you to generate a ZIO HTTP client. About JSON support, well, the library that has support for more JSON backends is the Tapir library. Endpoints for us also has some flexibility, but it supports less JSON backends. And the ZIO HTTP endpoints API just supports ZIO JSON now. So, and well, something interesting here that I wanted to mention, well, is that, well, if you're working with ZIO HTTP endpoints, you're just able to use ZIO JSON, right? But if you want to be able to work with any JSON library, you can do that with ZIO HTTP, but if you use the low-level API. So that maybe will be a good reason to use the low-level API in ZIO HTTP if you wanted to use other JSON libraries and not ZIO JSON. For XML support, well, Tapir is the only one that supports XML through Scala XB. For OpenAPI generation, all the libraries allow to generate OpenAPI, as we have seen. But well, currently, Tapir is the only one that allows to generate endpoints from OpenAPI definitions, so the other way around. I know ZIO HTTP endpoints will allow you to do that in the future, but currently that feature is not supported. Tapir also has some other nice stuff, like it allows you to generate async API docs, JSON schema, but ZIO HTTP has some nice features as well. It allows you to generate markdown documentation and a CLI for your API. So that's very nice. And regarding performance, well, ZIO HTTP endpoints, I will say, is the one that has the better performance because it uses prefix trees for route dispatching. So that's great. And well, the performance in the other cases will depend as well on the backends you generate, right? So in summary, the classic approach to building APIs is low level. Endpoints offer a higher level solution for us. Each endpoint library has slightly different features and excels at slightly different use cases. Use Tapir if you need multiple server backends, if you need to generate an AWS Lambda backend, if you need multiple client backends, support for multiple JSON libraries, XML, and multiple documentation formats. Use Endpoints for us if you need multiple client backends. Well, as you know, as I have mentioned, it also supports to generate multiple servers and things like that. But well, I think Tapir is better in that sense. And use ZIO HTTP endpoints If you need a ZIO native solution, superior performance, and automatic CLI generation. To learn more, you can visit the GitHub repositories for each library. If you are curious also about the CLI generation for ZIO HTTP, you can watch my talk. I'm including the link to my previous talk in the world about how to do this. And I will also be sharing the link to the slides so you have access to this. Special thanks to Zybers for organizing this conference, to John DeGose for guidance and support as always. And you can contact me on Twitter, LinkedIn, by email also if you want. And now I have my personal blog where I'll be adding, well, currently I have just links to my previous presentations, including the slides, but I'll be adding more stuff in the future. So thank you.